Hello ladies and gentlemen, and welcome to your video lesson for today. I am out of the building, and so this is a video of the same exact lesson that you would have normally during class. So the expectation for today is that you guys follow along with the class just like you would if I was here, taking the notes on the video just as if I was teaching it, and then come back next class with questions of things that you might not understand. You're still expected to try your independent practice tonight. There will be a homework sheet that you picked up in the back, hopefully, or the sub passed it out, and you should have your note sheet ready to go. So let's get started. The first thing that we got today, before we get started, this is kind of a forewarning here to the sub. Go ahead and please pause the video wherever I say to pause, and allow students to work, or if it seems like things are going too fast. Students, I'm certainly going to be going faster today than I would normally for a class just because, you're not here when I'm making this, and so you guys have the ability to pause. The other thing you need to know is that this video will be posted on Schoology, so if there's something that you missed, you'll be able to watch it in any time that you want. So there's really no excuse for not seeing this video and saying that it went too fast. You can always access it and get everything that you need. Like I said, come to class with questions next time if you have them. Let's get started here. So the first thing that I want you guys to do, if you haven't already, is to work on the warm-up here. It says find the next three numbers in the sequence. So try to observe a pattern that is happening, and then go ahead and write down the next three numbers. 1, 2, 3, and then try to observe a pattern that's happening here, and then write down the next three numbers, 1, 2, 3 there. And then also evaluate the expression for the given values. Remember, what we're doing here is if A is equal to 3, we're substituting in 3 for A. If B is equal to -2, we're substituting. Remember to substitute using parentheses. All right? So go ahead and give that a shot. Substitute. Please pause the video for students to go ahead and try it. All right, hopefully you guys have had time to work on those problems. If you look at the pattern in number 1, you should notice that we're subtracting 5 each time. And as we subtract 5, our next three values are going to be -6, -11, and -16. If you look at the next pattern, we have a couple things that are interesting, right? It's getting really big, really fast, which means, like, if you look at the common difference here, we're going down by 8. But we're not going down by 8 for this one, so we must be multiplying by something. Also, we have an interesting thing of this is positive, that's negative, that's positive, and that's negative. So how are we able to get a pattern that we're continuously doing something to, adding, subtracting, multiplying, dividing, so that we get this positive, negative value? Well, in order to do that, we're either going to multiply or divide by negative. Okay. No, remember, if you multiply a negative times a negative, it's positive. If you multiply a positive times a negative, it's negative. And so that's how we end up achieving the alternating sign numbers. So the pattern then becomes, if we multiply this by -3, we get 162. If you multiply that by -3, we get -486 and positive 1458, 1458. Cool. All right, for the next one. Remember, when we substitute, we have to substitute using parentheses. So both of them being substituted should look like this. Notice the 3's in parentheses, the -2's in parentheses, -3's in parentheses here. If we just focus on this one, then the work looks like 9 times 3 is 27. And then -4 times -2 is +8. We end up getting positive 35. For this one, remember, this -3 is in parentheses, so that means -3 times -3, which is +9, and then 9 plus 4 is 13. So those are the answers to your warm-up problems. All right, so cumulative review. So the homework that was due today, I'm just going to take the Schoology scores for. So go ahead and keep those for today. I'm going to look at Schoology for your independent practice and take those scores. So don't turn that in. All right, what are we doing today? Today we're talking about identifying and graphing sequences, okay? And our essential question is, what is a sequence and how are sequences and functions related, okay? So mostly today what we're going to be doing is taking a look at some sequences and identifying a rule from them, or actually vice versa. We'll be looking at rules for sequences and then using those rules. And we're going to talk about two types of rules, an explicit rule and a recursive rule. Both of them can do the same thing. They can both generate patterns, but they're used for different things, okay? So let's get down some definitions first. So let's do that off of this. So first of all, what is a sequence? A sequence is a list of numbers in a specific order. And there's a pattern that establishes that order. So like in the previous example, well, I don't have to talk about it. In the warm-up problems, we continuously subtracted 5. Or we were multiplying by -3. So we come up with the list of numbers by using some rules, right? And then a term is an element in the sequence, okay? So if I have the sequence 2, 4, 6, 8, 2 is a term. It's an element in the sequence, okay? In fact, I can give you a little bit more information about that. If the pattern is 2, 4, 6, 8, this is the first term. This is the second term. This is the third term, fourth term, and so forth, right? So we can have a sequence. Obviously, I'm just adding 2. And so we can talk about the number 2 but being the first term, and the number 8 being the fourth term. Just so some organizational things as we start talking about sequencing, okay? Because terms are going to be something that we use later on. All right, so first problem here. A go-kart racing track charges $5 for a go-kart license and $2 for each lap. If you list the charges for lap 1, 2, and 3, and so on in order, the list forms a sequence of numbers, right? So this is obviously the 5 plus the $2 for the first lap, right? And then plus 2 each time, right? We're just adding 2 from there on out. Our job is to write a function in function notation. And remember, functions in function notation always start with f of n. And then we want to identify what n represents, right? So n would represent what? It would represent the laps. So the function f of n would tell us how much it would cost, right? So the function would be, well, how much do we have to pay no matter what? Well, I'm paying $5 for that license no matter what, right? And then I'm adding to that $5 $2 per lap. So my function is f of n is equal to 5 plus 2n. And we could have used L for laps or X for laps or whatever, but that's what we got, right? And so if I want to know what f of 4 means, right? Well, f of 4, if I substitute 4 in, 2 times 4 is 8, plus 5 is 13, and it already tells me that f of 4 is 13. But what does it mean in the context of the problem? Well, what that means is that I took 4 laps, and it cost 13 bucks. Okay? And if we're talking about connecting it to what we've done in the past, I could have given you this exact question on the quiz, but we wouldn't have talked about it in a sequence. We would have talked about it maybe as making a table, right? And we would have our x and y values, and we can make a graph out of that. And that would certainly be something that we've already done. But now we can talk about the same information in terms of a sequence, right? As we looked at some of these equations from on our last quiz, we certainly saw that patterns form, right? So we're kind of exploring that in a very specific way, talking about sequences. Okay, so what we did in that previous problem is we actually defined something called an explicit rule, okay? I know we just wrote a function, but when we talk about all of this stuff in terms of sequences that can be generated from our functions, what we did is not just write a function, but we wrote what is called an explicit rule. An explicit rule is a rule that defines the nth term, okay? Now, the nth term is any term that I want to find in the function, right? So if we go back to the previous problem, 4, we found the fourth term in the function, and the fourth term in that function was 13, right? It's right here. So I could have found the 10th term in the function, the 20th term in the function, just by substituting in 20. Now, none of this stuff is really brand new, but again, we're just looking at this through a sequence lens, right? So back to the explicit rule. It's a rule that finds the nth term of a function of n for any whole number n greater than 0. What that means is that if I have the function, same one as before, f of n is equal to 5 plus 2n, that means I'm only going to use values of n that are greater than 0, and they're only going to be whole numbers, right? So n can only be 1, 2, 3, 4, and 5. And the reason for that is because when we talk about sequences, right, I can only have the first, second, third, fourth, fifth terms. It doesn't make sense to talk about the negative 20th term in a sequence, right? Sequences always start with the first thing that happens. And the first thing that happens is what happens when n is equal to 1. Right? So that's another thing when we look at our functions with the sequence lens in the explicit rule. N is either going to be 1, 2, 3, 4, 5, 6, 7, 8, so on. Okay? All right, so rest of the stuff. So this is going to be kind of a you do, or an I do, you do case, right? So I'm going to walk through how to write out the first 4 terms of a sequence. I'm going to do number 1, and then you guys are going to do number 2. So we'll pause the video after that. So in the past, if I just gave you this, and I didn't talk about a sequence at all, and I just gave you this table, I think you guys would probably naturally be able to do it, right? The only thing about what we're doing now and how it was different before is before we were choosing values like -3, -2, -1, 0, and then we did 1, 2, and 3, right? We said it was interesting to look at graphs on either side of 0. But when we look at this from our sequence lens, remember our n values can only be 1, 2, 3, 4, right? So that's all we're doing. I'm only interested in the first term, the second term, the third term, and the fourth term. So all I'm doing is substituting these values in for n, and then I'm finding out what the f of n value. Remember, that is also the same thing as y. Right, so let's just kind of do some mental math here. If I substitute in 1 for n, 1 squared is 1, 1 minus 5 is -4. Okay? So the first term is -4. What's the second term? If I substitute in 2, 2 squared is 4, 4 minus 5 is -1. So the second term is -1. So now, so far, we got a pattern of -4, -1, and so forth. Maybe we'll have something established here, maybe not. If I substitute in 3, well, 3 squared is 9, 9 minus 5 is 4. So now the difference here is 3, the difference here is 5, and I really don't have a pattern where I'm adding. Why don't I? It's a squared term. Okay, the squared term means that it's not going to be a pattern where we're adding and subtracting. All right, in the fourth term here, 4 squared is 16. 16 minus 5 is 11. So those are my first 4 terms. Why don't you guys go ahead and try that on number 2. Go ahead and substitute in 1, 2, 3, and 4, and find out the first, second, third, and fourth terms in the next problem. All right, well, I apologize for the sub there. I didn't say pause the video, but hopefully we're following along. What you should have gotten for the first term is 1, the second term is 5, and the third term is 9, and the fourth term is 13, okay? And again, all we're doing is substituting these values in, right? So for instance, we're saying that f of 3, that's a funky looking 3, is equal to 4 times that 3 minus 3. So we have 12 minus 3, which is 9. That's the third term in the sequence. Cool. All right. So this is how we can use an explicit rule to generate a sequence, okay? But we can do other things too, right? So notice it says it's a rule that defines the nth term, any term that I want to find. So let's look at the next couple examples. So in number 3, I'll do 3 and you guys are going to do 4. I want to find the 51st term of the sequence defined by the explicit rule f of n is equal to n squared minus 5. So it's the same rule, but now I want to find the 51st term. Okay, so all I'm going to do is, because it's an explicit rule, I can take this 51 and I can substitute it right in here for n, right? So I want to say that f of 51 is equal to that 51 squared minus 5. Okay, that's going to be a really big number. Okay, 51 squared is 2,601. And I'm going to take that and subtract 5. And when I subtract 5, I get 2,596. So what I can say is that the 51st term is 2,596, right? So again, what was I doing? I was given an explicit rule, the rule that defines the first term, the second term, the third term, blah, blah, blah. But I wanted to find the 51st, so I substituted 51 in for n, and I found out what it was. So go ahead and do the same thing for number 4. Please pause the video to allow students to work on that. All right, hopefully you guys had enough time to work on that. So if we're going to find the 101st term, this is the explicit rule that we use, and that 101 goes right in for n. So there's my substitution. Remember, I'm finding the 51st term, so it's f of 101, the function defined at 101, is equal to 4 times 101 minus 3. 4 times 101 is 404. 404 minus 3 is 401. And that means that the 101st term of the sequence, if I were to go out first term, second term, third term, all the way to 101, I would reach 401 at the 101st term. Okay, cool. Now, these two problems are the exact opposite, right? So the number 620 is a term of the sequence. What that means is that, so I have the first term, the first term, which I don't know, second term, which I don't know, right? And I don't know what term number this is, but one of these is 620. And I want to find out what value that is, or what term number, what term in the sequence is it, right? So there's a difference between a term value and a term number, right? The term number is like the first term, and that term value is associated with it. So how are we going to go about doing this? Well, if we look at the previous examples, what we did was we said that f of 101, or if we look at this one up here, we said f of 51, right, ended up being 2,596, right? So couldn't I have just also said that 2,596 is equal to the 51st term squared minus 5, right? So if I wanted to instead find out what term value that was, I could solve that for x instead, or n. That's exactly what we're going to do. We're going to take this 620, and now instead of going in for n, it's going to go in for the value of the nth term, because we're trying to find out the nth term. So we will substitute 620 in for the entire f of n, right? It doesn't look like f of 620. That means we'd be finding the 620th term. That's not what this is. This is replacing that entire value with 620 because that is the value of the term we're trying to find. So 620 goes in there, and that's equal to n squared minus 5. Now this n is the term number, right? So which term number in the sequence is it? Well, I just got to solve this for n. So the first thing that I have to do is add 5 on both sides. I have to start evaluating. So going back to the beginning of the year, what's happening to n? How do I solve for it? N is being squared, and then I'm subtracting 5. So the last thing I said was subtract 5, so the first thing I undo is subtract 5 by adding 5, right? So I get 625 is equal to n squared. And that's not the answer, right? Because we still have this exponent, so how do I undo squaring? I square root both sides. And the square root of 625 is 25, and so n is 25. So what that means is 620 is the 25th term of the sequence. Okay, so I want you to do the same thing in number 6. We're told that 125 is a number in the sequence, and we want to find which term number that is. Value in the sequence, we want to find out which term value. So that 125 is going to go in for the f of n. Please pause this video to allow students to try example number 6. All right, so hopefully you guys had enough time to go over that. So again, here's my substitution of the 125 in for f of n, and then I just solve for the term number. Okay, so what's happening to n? I'm multiplying by 4, and then I subtract 3. Last thing I said is subtract 3, so the first thing I do is add 3 to both sides. I have to undo that. So then I end up with 128 is equal to 4n. What's happening to n? It's being multiplied by 4. How do I undo that? I divide by 4, and then 128 divided by 4 is 32. What that means is that the 125 is the 32nd term in the sequence. So if we started out with the first term, second term, right? We don't know what those are. Third term, all the way up to 32nd term, we would know that that's 125. And we don't need to know any of the other previous terms. Okay. So that is what we're going to do with the explicit rule, okay? And like I said in the beginning, the big advantage to the explicit rule is that it defines the nth term of any function. And we don't need to know any other previous values without finding any previous terms, right? So I didn't need to know, like if I was finding the 32nd term here in example 6, if I'm finding the 32nd term, I didn't need to know terms 1 through 31 to find the 32nd, okay? Now, in a different type of rule, which we're going to talk about next, the recursive rule, we do have to know all of the previous terms to find the next one, right? So, explicit rule. A disadvantage for the explicit rule is that we don't know any of these values, right? But we can cut right to the values we want to know. The recursive rule we talk about next, well, the advantage is we'll be able to build the sequence, we'll know the little values, but we won't be able to find the 101st term very easily. All right, so the recursive rule. The recursive rule is a rule for a sequence that defines the nth term by relating it to one or more previous terms. Specifically, it's going to be the term right before it, okay? Now, the notation here, you really, like right now, you guys really got to dial in on what this means, because if you look at this later and you only half pay attention right now, this is going to look really confusing. So let me break down what this means, okay? Now, notice I have like different colors for this example right here, all right? So for this example, I have different colors. When you write your own recursive rule later, everything that is in red is just part of the rule. Okay? This part right here, the f of 1, means the first term. So you can even write that down. F of 1, first term. So if I was going to start out making the sequence, I know that the first term is 4. Okay? I know that the first term is 4. So that's what that means. This part means the value of any term is then equal to, and then the n minus 1, right? If I know the first term, if I substitute 1 in for this, you will never substitute anything in here, by the way, but I'm just talking you through this. If I do put in 1 here, right, 1 minus 1 is 0. I'd be talking about the term before it. But if I want to find the second term, then I would need to subtract 1 from that. So the second term would be the first term plus 10. So if that was maybe a little bit confusing, here's really all you need to know. All this means is value of previous term, which is the first term, right? Value of the previous term. And then what do we do to it? We add 10. So that's how we build our sequence. So if I'm looking at this rule, I know that the first term is 4. And if I want to find the second term, I say, all right, well, take the value of the first term, which is 4, and add 10 to it. So it's 14. And then the third term, be like, all right, well, take the value of the previous term, which was 14, and add 10, which is 28. And literally, all we're doing is continuously adding 10. So the next one will be 38, then 48, then 58, then 68. Okay? So that's how this works. All right, so the rule means that after the first term of the sequence, every term, f of n, is the sum of the previous term. Previous term means f of 1 and 10. So here's how this rule works. Again, we'll do this you do, I do thing. And let's look at number 7. So this means, again, first term. So I already know right away if I'm filling out this table, the first term is 35. It's telling me. And then this means to take the previous term, which if I'm finding term number 2, the previous term is 35. And then I take 35 and subtract 2, which is 33. And if I want to know the third term, I got to take the previous term, which is 33, and subtract 2 again, which is 31. And then I subtract 2 again, and I get 29, and that would be the fourth term. And then I can continue to subtract 2, okay? So notice how this builds the sequence from the very first term to the second term to the third term, right? I cannot use this. Well, I could, but it would be super inconvenient and be a really, really mean quiz or test question. If I said, all right, here's the rule, find the 102nd term. Because that means you would have to do the subtraction of 2 102 times, and that's not fun. All right, so go ahead and try that same thing on question number 8. Please pause the video for them to work. Okay, hopefully students had enough time to work on that. This means that the first term is 4. So in the table, first term is 4. Voila. And now this is a little bit out of order. Typically you won't see it this way, but it doesn't matter. This still means take the previous term and do what? Multiply by 4. So what's my previous term? It is 4, and then 4 multiplied by 4 is 16. And then I take the previous term again, 16, and now multiply that by 4. So 16 times 4 is 64. Multiply by 4 again to get 256, and so forth. So that is working with the recursive rule. All right. Now, I want you to kind of do the same thing with questions 9 and 10. All right. You're given recursive rules, and I want you to go ahead and write out the first 4 terms of the sequence. I don't think, they're not in table form, but it doesn't really matter. You should be able to do this anyhow. So go ahead, please pause the video for students to work on questions 9 and 10. All right, so recursive rule tells us that the first term is -5. So boom, there it is. First term is -5. Then what are we doing? We're taking -5 and we're adding 12. So -5 plus 12 is 7. If I add 12 more again, take the previous term, add 12, I get 19. Add 12 again, I get 31. And the next one, number 10, suppose I can get rid of the shade. The value of the first term is -4. So there's -4. Then what am I doing? I'm taking the previous term and I'm multiplying by -2. So multiplying a negative times a negative gives me +8. I multiply that by -2. Now I get a -16. I multiply that by -2 and I get a +32. All right, so those are the kind of the bare bones things about explicit and recursive rules. So kind of to go back, remember the explicit rule just gives us, there's only one part, right? So if you're ever identifying like, is this explicit, is this recursive? The explicit rule only has one part, and it allows us to go to any term we want to, but it doesn't allow us to build the function very easily. I mean, we did it here, right? But it's not like we completely just added, or multiply, right? And then the recursive rule has 2 parts. It tells us the first term, and it tells us the way to build it, okay? So those are the main differences between your 2 rules. All right, last example here, and then we'll be done for class. So real world example, right? A museum charges $10 per person for admission and $2 for each of 8 special exhibits. Okay, so So it says use function and function notation to write an equation to represent the cost of attending n exhibits. So if I know if I'm writing a function and function notation, that's going to be f of n is equal to something, right? Or f of x, but I used n because it said to use n. And I have 8 potential exhibits to look at, but I know that I'm going to pay $10 no matter what. I walk in the door, they pay me $10, so there's the $10, and I'm adding to that cost $2 at a time, depending on the number of exhibits that I attend. And there are a total of 8, right? So it says make a table that shows the cost of admissions for 1, 2, and 3 exhibits. Now, that is allowing us to go ahead and write a explicit, well, this really is our explicit rule, if we think about it. That's what we would write for our function. And now using that explicit rule or this function, we have ticket values or tickets for 1, 2, and 3 exhibits, right? Well, what's it going to cost? Well, if I substitute in 1, 2 times 1 is 2 plus 10 is 12. If I substitute in 2, right? 2 times 2 is 4. 4 plus 10 is 14. If I substitute in 3, 2 times 3 is 6, plus 10 is 16. Awesome. All right. So that would be using the explicit rule to generate what's happening for that scenario going to the museum. And it says f of 0, well, I don't have to write that down. What would f of 0 equals 10 represent, right? Like in real life. What would that represent, right? So let's go back to the scenario. It's kind of interesting. A museum charges $10 per person for admission and $2 for each of the special exhibits, right? So f of 0 means what? It means you basically walked in the door, paid admission, and then didn't attend any special exhibits, right? So I don't know what that means. Maybe it's a museum that didn't have anything but special exhibits, and you just walked in, gave $10 and walked out. I don't know. But you didn't go to any of those special exhibits, right? So you walked in, donated $10. So it's basically paying for admission and no special exhibits. Which is weird. Why would you go to the museum then? I don't know. Maybe there was a cool gift shop. All right. So moving on, kind of using that same example now. It says now we're going to graph the sequence. So I'm going to go ahead and label my axes. This is going to be the number of exhibits. If we go back, this is like previous quiz stuff, right? If we wrote this function, this is going to be my dependent variable. This is going to be my independent variable. And what is my independent variable? It's the number of exhibits that I attend. The number of exhibits that I attend affects the cost. My cost is dependent on the number of exhibits that I attend. So that means this goes on your x-axis. It's the independent variable. So number of exhibits, we're going to be at that EX, and this is going to be my cost, right? And so I will count by halves, I guess. So that'll be 1, that'll be 2, 3, 4. No, I can't attend a half exhibit, but this kind of stretches out my graph because I have potentially 8 to see, and now I have 8 spread out pretty well on my x-axis. If I attend 8 exhibits, how much is that going to cost me? Well, 8 times 2 is 16. 16 plus 10 is 26. So I got to cover at least a 26 on my graph, so maybe I'll count by 2s, but only label every other. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. And I know that's as high as I have to go. So what is my graph going to look like? I know that at 0, I have to pay $10, which is kind of the bummer exhibit expense, but it's true. And I know that 1 is going to cost $12, right? I know that 2 exhibits is going to cost $14. And so my graph kind of goes up like this. 3 is going to cost me $16. 4 is going to be 18, going up by $2 per exhibit. 5 is going to be 20. 6 is going to cost me 22. 7 is going to cost me 24. And 8 is going to cost me 26. Quick question for you. Should we connect those points or not? Is it discrete or not? Discuss for 30 seconds with your groups. Pause the video. All right, it is a discrete scenario. I can't attend 1.5 exhibits. I don't know how that would work. I don't know. I don't think it's possible. So this is not meant to be connected, so that's what your graph looks like. It is a discrete scenario. It is a discrete graph. What would the total cost of going for all 8 special exhibits be? You could answer that on the graph, right? So 8 exhibits, go up to the point. What would that cost? $26. And so it'd be, we know it's $26 according to the graph, but let's see if the equation supports that. What that would be is f of 26, not plus, is equals, I did the right thing. It's not f of 26. I'm not going to 26 exhibits. I'm going to 8. So f of 28. Ugh. F of 8. Going to 8 exhibits. F of 8 equals the $10 admission charge plus $2 times the 8 exhibits I attend. All right. That would be 10 plus 2 times 8 is 16. And voila, we got what we thought we'd get, 26. So 8 exhibits would be $26. Now it says write a recursive rule to represent the situation. All right, recursive rule. Remember, we already talked about how what we wrote here, the original thing, f of n is equal to 10 plus 2n. We called it a function, and it is a function, but really, in terms of if we're creating a sequence, which is what we're doing here, this is the lens in which we're looking at everything, this is an explicit rule right there. But the recursive rule doesn't look anything like that, right? It looks totally different. So let's go back one more time and review what the recursive rule looks like. So remember way back when I said everything in red is just part of the rule, right? And that's true. So I need to have f of 1 equals something. So I go back. Oh boy, there's going to be a lot of back and forth here. So f of 1 means the value of the first term equals something. Well, what is the first term? What does it cost to go to 1 exhibit? It's on the graph here. It cost me $12, right? So the first exhibit cost me $12. Okay? Then, let's go back. What other form stuff do we need? We need an f of n is equal to f of n minus 1. That means the value of any term is equal to the previous term, and then we add or subtract or multiply that previous term. Let's go back. Without even knowing anything about sequence, I know for sure, because of the form, that I need f of n is equal to f of n minus 1. Again, the value of any term is equal to the previous term, and then we do some stuff to it, okay? What stuff are we doing? If we're taking that previous term, and if we look at the graph, aren't we just like adding 2 every time, right? From 0 exhibits to 1 is $2 more, $2 more, $2 more. So that's what we're doing. Plus 2. There it is. And that is your recursive rule. So again, how can I use that rule? I know that the first term, second term, third term, fourth term, fifth term, right? First term is 12. Second term is 12 plus 2, which is 14. And I take the previous term, 14, plus 2 to get 16, and then 18, and so forth, right? So see, it's all connected. All right, so your independent practice tonight is going to be working with those explicit and recursive rules. It is lesson 4.1. You should have received a handout that had those problems on it. And remember, there is a Schoology component with your independent practice. Make sure that you do that as well. You guys should have a decent amount of work time This looks like it took me about 40 minutes, so you guys should probably, you should probably have like a half an hour work time right now, I would think. So go ahead and use your time wisely, tackle it. Come to class next time with questions. I'll see you guys. It's going to be next week because we're off. All right, adios. Have a good weekend.